In recent years, both network traffic patterns and end user behavior have all undergone significant transformations. In 2020, we scrambled to enable remote work. 2021 was all about responding to the office's reopening, and 2022 is all about adapting to hybrid work. So, what does all this mean for 2023? Well, according to research from Worldwide Technology, this is the year we shift from wait and see to deploy where applicable. And it's all covered by the 2023 Networking Priorities Report. In fact, one quote, "We see 2023 as a year marked by acclamation rather than response, a year in which networking leaders can take a breath and get back to driving their organization's multi-year initiatives." Well, that sounds good to me. Hybrid work is here to stay.
The office is changing. We're seeing fewer and fewer of our customers saying, my people are going to come back and work in a queue.
Most of us have a good handle on end user behavior as well as the traffic flows, which means that our network investments can align directly with the employee experience. Well, here's a list of priorities. Update your wireless strategy, expand SD-WAN, move on Wi-Fi 6E, consider private wireless. So what jumps out to you from this list? Wireless, maybe? So I said to myself, we should look into this further. So I reached out to one of the authors, and he agreed to entertain my litany of questions, and I think they're all worth sharing. My name is Rob Boyd. Welcome to Tech 37, your home for technology, education, and collaboration from Worldwide Technology. All right, Bob Hrbek, welcome to Tech 37. Appreciate you taking the time.
Thank you.
Yeah, good to have you here. The idea of, we have a singular guest, we're going to do a deep dive here on specifically the wireless portion of the network priorities for 2023. That is something you're used to talking about, but for anyone who's not familiar, who are you? What do you do for Worldwide Technology?
Yeah, Bob Hrbek. I'm a practice manager in our global solutions and architecture team here at Worldwide, and my team focuses on campus technologies around switching, Wi-Fi, location services, as well as IoT connectivity and private wireless, which is kind of that private 4G, 5G, CBRS band networking.
Today, obviously, we want to talk about wireless. And I think the biggest thing that jumped out to me is this notion of just automatically defaulting to, when you say wireless, I think Wi-Fi. And I think that's one thing that jumped out at me, is that you can't think of it that way, because that would be really cutting you off from the possibilities. But we mentioned wireless strategy as the first one. And so that's a lot to encompass. And there's some specific technologies I'd like to get into with that. But how would you set this up as the importance, or maybe this, what is different about how we're looking at this set of technologies strategically now versus how we might used to have been doing it?
Yeah, that's a great question. And the way we kind of explain this to most of our clients is that wireless is a little bit of a platform today. And there's a bunch of different ways that you can use wireless. It is more than just Wi-Fi, but that Wi-Fi network can do things like provide location services alongside BLE or Bluetooth Low Energy. But there's other wireless technologies that might be more suitable for the use case that the client is trying to deploy. Things like LoRaWAN for IoT connectivity over long distances. Things like private wireless or private 4G, 5G networks that can be deployed, owned by an organization, and utilize those 4G and 5G technologies to provide connectivity over large distances, provide a very low latency or very prescriptive latency connections, and do things around roaming and device coverage that we're just not able to do with Wi-Fi, but even be deployed alongside our Wi-Fi network. So it may not be replacing that network. It might be augmenting it for a special use case or a higher priority connection type outcome.
What are the things that are important to consider? Where are the traditional, perhaps, dividing lines between applications that maybe make them ripe for saying, hey, you should look at some different set of technologies here? Is it industry line usually the best way to do it, or does it get, I'm sure it gets much more specific, but how do you go about that?
I think there's a lot of education around what wireless connectivity can do for you. And traditionally, it was a nice to have in an office. It was something that we built for a coverage model. We wanted to provide that connectivity as people left their desk and went to a conference room. but we're seeing more scenarios where this is the primary method of connectivity. It's no longer a nice to have, it's a must have. It's replacing the wired connections. And we're leveraging it to deliver voice connectivity. So, throughout the pandemic, we're all at home working. Most of us are home working on through collaboration tools, utilizing our home Wi-Fi network. We go back to the office with that same laptop we worked at home, and we're expecting that Wi-Fi network to carry our voice and video traffic. And we've been telling customers for years that the volume of data going across the network, and even the volume of real-time data going across the network, is going to grow exponentially. And the catalyst of that was likely the pandemic in introducing and normalizing video communication and voice going across the internet and going across those wireless networks. And now that's in the office. So we have clients that are asking us, help us deploy a call center type network where we have nothing but soft clients on our laptops. We're going to have our agents work wherever they feel like they want to in the building. But also, outside of a call center type scenario, the office is changing. We're seeing fewer and fewer of our customers saying, my people are going to come back and work in a cube. That's theirs with their family pictures on the wall. We're seeing more of our customers say, we're going to have our employees come in and work in a hotel desk, and they might work there 1 or 2 days a week. It's likely not going to be the same desk each time. There may be even more scenarios where they're working in more of a collaboration space. They come into the office to meet with their peers, to do some things that might be a little bit more difficult remotely, or to just build that culture and kind of keep the connection between employees going. But it's less of a home and it's more of a temporary location. And to add with that, then clients are saying, how do we know how the office is being used? We can look at traffic going through the branch routers, but I don't really know where people are at in that building. I may not know how often the conference room is being used or how often my hotel cubes are being used. So they're looking at some of the location services capabilities. And that may be Wi-Fi location services, which doesn't give us real precise location. It could be BLE or Bluetooth location services. We're seeing that BLE radio being integrated into access points so that you have this, again, a platform that can now do more things. It's not just a Wi-Fi connectivity, even infrared to get down a little more granularity of how long did that person sit there. If I don't know, if they don't have a phone or something else I can track the infrared profile of an individual versus a monitor or a laptop and things of that nature. But get a really good understanding of how often these spaces are used throughout the day, how many hours a day, and maybe indicate that it's time to refit my office with more of a particular type of space over the other.
Have we moved already to the point, like if I'm deploying a whole new floor, let's say in an office building, are we still doing network bundle cables to a place where we think a cube's going to go? Business critical things can happen in a properly constructed wireless network, and you don't have to necessarily worry about cabling to specific physical places?
It definitely de-emphasis on wiring everything together. We are seeing more things being wired that require power. So PoEs, suddenly something of greater interest, and might be an element that differentiates some different switching models or vendors from each other, is being a more significant thing to support the resiliency of the operation of that office. So if switches are sharing power through stack power, sufficient battery backup, there's a battery blip. We don't want everything in the office to reboot. Less reliance on more of the traditional tethering type devices. Plug in your computer in to charge it. If you plug a PoE device in, plug your laptop in to pull PoE from the network, or even sensors around the network that might measure occupancy, air quality, temperature, and other IoT type services relying on that PoE.
One of the things that was brought up in the priorities, I don't remember which priority number it is, but it was being specific about saying, last year we said, watch this space around Wi-Fi 6E. Can you break down what is different about 6E versus previous generations, and why would we say it's now ready for prime time?
Yeah, I'd probably step back and say Wi-Fi 6 and 6E, okay. A little bit lumping them together. when Wi-Fi 6 came out, it was a greater improvement of throughput, latency, being able to service a greater number of clients. And it was not only for the 5 gigahertz band, but it was for 2.4 gigahertz as well. So a lot of folks have been trying to move away from 2.4 gigahertz, saying, hey, it's a little bit of a junk band. It's been around forever. There's too many things. There's too much interference. It travels too far. And most of the advances we saw in prior versions of Wi-Fi were more related to improvements in the 5 gigahertz band. Wi-Fi 6 brings those same improvements to 2.4 gigahertz. Along with that, we have multi-user MIMO, so being able to talk to multiple clients in the same time slice in upload and download directions. So we're not only able to optimize download traffic, but we're able to optimize that upload traffic as well. So improving real-time traffic, if we're sending video and voice from our wireless devices, having a greater capability to ensure reliability of that delivery. And Wi-Fi 6E then is just an extension of the frequency bands that are available. There was a low 6 gigahertz band that was previously in a protected space for outdoor point-to-point connections, mostly seen in kind of a carrier type network, not really utilized in an urban environment. That was really more of a rural type communication band, very long distances outdoors, big giant dishes. But the FCC said, hey, we need more spectrum. Let's repurpose that for indoor use. We will be able to use it outdoor as some other spectrum access coordination things come into play, so that this new Wi-Fi 6E doesn't interfere with those existing outdoor point-to-point links. But it's a third radio in these devices, and really needs to be thought of as almost a totally different Wi-Fi. Think of it like a different Wi-Fi SSID. You're not going to broadcast corporate SSID 123 in 2.4, 5 gigahertz and 6 gigahertz at the same time, because there's not backwards compatibility between those devices. Wi-Fi 6E requires WPA3, whereas 6 can, in the 2.4 and 5 gig bands, can use WPA2 or 3. But
just to make sure we're straight on that, that's the security and the authentication process that are happening in that. And when you talk about WPA3, is that what it was?
Right. So WPA2, AES is the preferred method to secure or encrypt the communications between the client and the access point, and vice versa. WPA3 is an extension to that, which offers a bunch of other flexibility. One of those key things is open authentication. So if you walk into a coffee shop today, you connect to their Wi-Fi network, there might be a pre-shared key written on the chalkboard that you can use. That's not really security. It's maybe a security through obscurity. But WPA3 open access allows us to connect to a public Wi-Fi network and have a key dynamically shared with my client through that WPA3 architecture, and ensure that I have a secure connection, much like I might in my corporate environment. So really kind of interesting there, adding additional layers of security, but also the evolution of that WPA connection method altogether.
Well, that means that process is that much more invisible, yet still secure but that's just great for end users, and thus great for a business, potentially, for just lowering the friction of it. Because I hate doing the keys, and I hate doing the page, and how well that's implemented in the airport or whatever it may be.
The challenge with 6E and having that third radio is around device support. And today we use a term called band steering, where we try and steer clients from 2.4 to 5 gigahertz because the traditional additional capacity in that 5 gig band, whereas that 6E, the additional spectrum, is going to enable us to deliver significantly greater data connections. So in the Wi-Fi 6 and prior versions, we can configure large channels, but that doesn't leave us a whole lot of channels to deploy within the network.
What is the capacity difference if we're looking at the 6E band? What is that enabling us to do differently?
A great question. So in that 6 gigahertz band, we have 1,200 megahertz available to us to slice up into different channels. And the kind of recommendation today is to start using these 80 megahertz channels, which traditionally wouldn't have left us with very many usable channels in that 5 gigahertz band. But in that 6 gigahertz band, we have up to 16 channels at 80 megahertz. And at an 80 megahertz channel size, we can deliver an air rate of around 600 megabits a second. So our data rate's going to be about half of that, but significantly greater than we've seen in the past, and even a greater volume of data over a large area, because we're able to use those 16 channels throughout, 16 different access points in an area. It gets into even a little bit further discussion around how do we then connect that access point to our wired network, because obviously there's got to be a connection there. And on the switching side, we're looking at multi-gigabit speeds now. So it's not just a 1 gig copper connection to that access point, but 2.5 gig or 5 gigabit per second connections to that access point. That does drive cabling changes. So we absolutely have to have 6E cabling to those APs, and maybe even Cat7 cabling to support those higher speeds, but shrinks our distance that we can get from our switches to an access point to support those significantly higher speeds across copper.
And that's just a confusing overlap of naming, is it not, when it comes to 6E cabling versus Wi-Fi 6E? Okay, just make sure I understand.
I almost struggled when I said it, but it's got to be said.
Yeah, no, when you look at 6E access points, there's an additional, not only just the bandwidth coming off there, you're looking at 2 cables of higher grade running to that, as well as for the PoE support, because the standard I know has come up quite a bit with how much power we can deliver on a twisted pair. But what's the status on implementing that?
We are seeing access points with 2 copper connections coming off of them, which would be either resilient PoE, so pulling PoE from 2 different access points, or combining the data connectivity to that access point to reach those higher speeds. If you start doing the math in your head, if I have 10 people connected to this access point, and each one, probably you're going to have more than 10, but just for easy numbers, 10 people pulling 300 megabits a second, that's 3 gigabits a second from an access point. You're not going to get that unless you have significant wired connectivity to it.
Yeah, it's so funny because we didn't used to have to think about our clogging, our points of where the lines get clogged is moving back more towards the core. But that's different, because obviously if you're cabling, to your ceiling and different things like this, we might historically have run, this is awesome, because remember the stories we'd always tell us, I only got to run 1 cable. I don't have to bring an electrician in to do conduit. And so some of that still holds true, but you better be running at least 2, if not more, because we know it's always cheaper when you're first running the cable to run a little bit more than you need, just in case.
Absolutely. The second cable, you're only paying for the copper. So.
Well, it sounds like also with that gargantuan, highway lines exchanging bandwidth that pretty much meets probably 95% of most people's application needs. But when you go to an office, suddenly you're looking at wireless design specifics, and you're wanting to analyze your environment and the structure in your environment, how that changes, where people move. Does that get easier or harder with these additional channels and capabilities in 6E?
It could conceptually get a little bit easier, but because you have more spectrum, less interference. However, for some time now, we've been moving from architecting Wi-Fi deployments for coverage and architecting them instead for capacity. So instead of having the lowest bit rate that you might be able to connect with being okay at the edges of our office building, we're deploying or locating access points so that we're able to get the highest bit rate at as many locations as we possibly can, and even overlapping coverage from access points, so we have additional resiliency. If an access point were to fail, we're able to cover that area with a alternative access point. So gotcha. Design is changing a bit. Certainly, as we start to include other things like 6 gigahertz, there's a bit of an impact to that as well. That is a spectrum that we can use higher power in internally. So need to consider what power level we're deploying that at, and also how many devices are going to connect to it, because it's not backwards compatible. Your device has to support 6E for you to connect to that 6 gigahertz channel.
So you got to know how many compatible devices at a given time would even be in the environment trying to make that connection, I guess.
And there's quite a few of them out there today. The newer iPhones, newer laptops, things of that nature. That the higher end stuff, but anything that you bought 2 years ago probably can't support that spectrum.
So, and I think you said 2.4 is still part of a 6E radio, or is it
Yeah,
only
it
part
is.
of the 6 radio?
So, I mean, a 6E
And what are
radio
we
has,
using that for? Because that changed. Because I imagine that is because of its ability to transmit longer distances, perhaps break through different, because literally the bandwidth is a different shape. It's going to travel through certain objects better. Does that mean that there's a good reason, not just for backwards compatibility, but there's a good reason maybe to specifically engineer for certain types of connectivity with 2.4?
So in Wi-Fi 6, 2.4 gigahertz inherited the similar capabilities to the 5 gigahertz band with the upload and download multi-user MIMO,
Multi-MIMO? Okay.
as well as the higher data rates. Some of the other enhancements within 6 gig or within Wi-Fi 6 made it into that 2.4 gigahertz band as well. So it increased the capability of that band to service a high number of clients, to be able to communicate with multiple clients in both the download and upload capacity. So it kind of reinvigorated that band. I mean, you think of, bad analogy maybe, but throwing a cool carburetor on that old car, like suddenly it's got a lot more oomph. We upped the horsepower there for sure.
It's so funny because I feel like that's becoming an old guy reference when we talk about carburetors. Right? And no offense.
The whole difference between 6 and 6E, it's 6 is 6E, but 6E is all that 6 has plus 6 gigahertz. So the two stand, you don't gain anything with 6E other than the 6 gigahertz spectrum.
We led this conversation talking about wireless does not equal Wi-Fi. Can you contrast what's the difference between Wi-Fi and I'm just going to say LTE for short?
The private industry has been impacted by the marketing of the carriers a bit. 5G has turned into a bit of a marketing term that means you're super awesome. In reality, there's a lot of standards that fall into the 4G and 5G segments of that technology. But from a private perspective, the FCC allocated recently a set of spectrum that was once reserved for radar. It's called CBRS, and it operates in this 3.5 gigahertz band. And it's a bit of a licensed light type architecture where there's a spectrum access provider who you can check out a channel based on your geography. So your access points have a GPS location, power levels, antenna patterns, and things of that nature, so that spectrum access solution can make sure you're not interfering with a priority user in that band. But again, this is a technology that can be deployed alongside Wi-Fi and not interfere with it. And it's also something that brings with it all of the enhancements that come with LTE or 5G around low latency, predictive latency, a greater level of security based on SIM card type access, or whether it's physical or electronic. But it's a technology that can do a lot of things that Wi-Fi can't, even if we're looking at 6 or 6E. And the things that it's really good at is that prescriptive latency. You're going to have the constant, about 22 millisecond connection delay between any devices and the rest of the network. But the roaming capabilities, as well as the area that it can cover, is significantly superior to Wi-Fi based on the power levels that are available, based on the modulation schemes and how the devices are able to utilize the RF spectrum. So we're seeing some huge use cases in warehouses and in manufacturing, and some interest around healthcare. We're still kind of developing that a little bit, but outdoor spaces, ports and airports. Think of scenarios where people have handhelds, or we have sensors, what might even be cameras, and it's difficult to connect them because things are moving around, or the device itself is moving around. In a warehouse, it's pretty easy to visualize somebody walking around, in the Amazon warehouse with a barcode scanner, scanning an item, throwing it into a box, or scanning a box and dropping it on a belt. But those devices work in very harsh RF environments, and whether it's interference or obstruction of other devices, or obstruction of from pallet racks and things of that nature, that CBRS or private LTE network is able to use a controller-based roaming architecture.
Give me an example of where we would today say, hey, you should really be looking at LTE versus trying to fight your way through making Wi-Fi work in that area? What would those be and why?
An example use case might be in warehousing, and we're seeing this really being fairly popular along with manufacturing. But imagine a warehouse environment where we need to connect sensors on forklifts and handheld scanners to read barcodes and connect back to the inventory management system, so we know which box we're picking and assembling for shipment. It's really hard to cover a warehouse with Wi-Fi. It requires a large number of access points. There's a lot of obstructions. We get run into interference issues, and that network is
used a lot.
Yeah, absolutely. Things moving around.
Yeah.
Inventory moves around. We don't know what's in the boxes, but that network is used not only for those handhelds and those, kind of operational devices moving around, but for the people working in those warehouses with traditional devices like a laptop. So there's a little bit of diverging use case going on there where we need to provide some connectivity for typical devices, but also devices that don't act typically. And private LTE can really benefit an environment like that. Number one, we can use significantly higher power from the access point to connect those peripheral devices. So that means we can cover that space with fewer access points. The second thing is a LTE or 5G network. The roaming is controlled by the core. So in our Wi-Fi networks, we usually have a controller that we can push out configuration. But in a 4G, 5G network, we have a core that runs a lot of different functions, among them security and routing, but also roaming. So that core initiates a client to roam from one access point to another based on not only how the access point can hear the client, but an understanding of how well the client can hear the access point. So we would see fewer scenarios where we get like that sticky client that tries to hang on to one access point as it moves across the building, and really the access point can't hear it. We get a lot better efficiency and reliability from a private wireless network than we would a Wi-Fi network. So we're already seeing some huge cost savings, huge reliability improvements, and overall user experience improvements in private LTE networks in that warehouse environment. There's other scenarios where we're starting to see in manufacturing and healthcare more autonomous vehicles. And don't think of it like a Tesla driving down the road as much as a robot that might be moving parts from point A to point B, or in healthcare, it might be a robot that's carrying dirty laundry down to our laundry facility, or bringing clean laundry back, or even delivering meals. These are it's low value activity that can completely be automated to ensure that the high value workers that are in those facilities are able to do more tasks more efficiently without folks interrupting that supply chain process of getting parts to where they need to go from where they came from.
Hybrid work is here. It's there. It's everywhere. But for someone to be able to work from here or here, there has to be someone here, making sure everything is safe, secure, consistent. So go ahead, log in from here, dial in from here, sit in from here, assured that someone is here with a view of everywhere, ready to fix anything, anytime, anywhere, even here. That's because nobody, and I mean nobody, makes hybrid work better. Cisco, the bridge to possible.
And are there certain applications in certain places that need a timing? Maybe in the autonomous piece, I could see maybe working into that, where that is another reason LTE gives you just a more reliable, consistent delivery model.
Absolutely. So especially in a hospital, we heard examples and work with clients to overcome issues around those autonomous vehicles. When they lose Wi-Fi connectivity, maybe they get by, and a hospital is a really difficult RF environment, just as a backdrop. A hospital that's been around for 50 years, the X-ray room may have moved a couple times. There might be lead in the walls. There's a lot of metal. It's a really difficult place to provide connectivity, but those autonomous vehicles often will completely stop movement if they lose network connectivity. And somebody has to go behind them and push them 5 foot in front of the elevator, out of the path, so that they reconnect to the network and are able to start working again. In things like warehousing, manufacturing, even ports, if elements of that facility lose network connectivity, they lose the timing that synchronizes everything together, and everything might stop. So there's huge expense to the day-to-day operations if everything stops. But those are some of the more challenging environments where wired connections are really, really difficult. And most of those scenarios don't need high data rates. They need predictable latency and high reliability. And that's what private wireless delivers. It's not yet really a technology that is going to replace Wi-Fi as we see some marketing of 5G LAN, replace all your Wi-Fi with 5G. The technology is not there yet, and we don't have enough devices that really deliver it. It's an opportunistic goal, but this private wireless technology is really something that should be used in special use cases, hard to connect areas, outdoor areas, large venues. We are seeing some interest in, say, like a NFL stadium or something of that nature, where you have the barcode readers checking in tickets. You have retailers taking credit card payments. You have other cameras, security devices, people walking around that need to capture data, receive data, send data, whatever that might be. Just private LTE being a much greater, a much more reliable method to do those things over a broad area. And we can, again, deploy it alongside Wi-Fi. So we can have our Wi-Fi network that we continue to rely on for things that are very high capacity, but not really important. And then leverage things like private Wi-Fi for those unique use cases.
Is there a dividing line saying that for the most part, user traffic and PC traffic and stuff we're probably going to do on Wi-Fi in most environments, especially carpeted environments?
Yeah, definitely.
Not in LTE, we're leaving it to devices, or is that a little bit too simple to try and state it?
I think that's actually a really simple lane to put it in. I think our laptops and the users likely continue to stay on Wi-Fi. Whereas the IoT type applications would greatly benefit from moving to something like private wireless.
And what's the client environment like these days with private LTE? Are they making radios in enough different applications at a low enough cost to make that useful?
They are. So there's a huge vendor ecosystem that's spinning up in that environment. We're partnered with a number of them. Qualcomm, Intel, both working with us really closely to identify the devices out there that have their chipsets that support different technologies, so that we have a ready database we can exchange with our client and say, hey, this is the stuff that will work with the network you're trying to deploy. It's getting bigger. It's certainly not as broad as Wi-Fi is today.
Yeah. Well, but I also wonder, especially when you say IoT, what's the battery impact on those type of things? Can devices run longer? Can they be woken up to transmit if they're not constantly transmitting?
And Wi-Fi 6 introduced target wait times. So we kind of have a similar model of don't connect to the network or don't send data for a little while. We're going to put you to sleep and allow you to power down a little bit. But if we're talking sensors and exceptionally low power, and especially in a private environment, LoRaWAN may be that technology, that wireless technology that is much more applicable for that use case. We haven't talked about it yet, but it's a very low frequency, kind of going back in the day at this 900 megahertz ISM band that was around in the 90s. It got flooded by
cordless
monitors,
right?
And cordless phones and things of that nature. And, everything used it. And still a lot of stuff does, but LoRaWAN is a technology that outdoors in a urban, city-ish environment, we can easily go 2 miles. If you go more rural environment, there's folks that are easily hitting 3, 4, 5 miles with that connection. It's not intended to be any high capacity bidirectional communication. There is some bidirectional element to it, but it's intended to really be a reception of a sensor transmission. So think of water plants where we're measuring the water temperature and turbidity and chlorophyll and other elements going on in that water. Rather than wiring all these sensors back, you can have a LoRaWAN gateway. The sensor connects through Modbus or whatever, and is able to send that data back to a collection point and do that over a great distance. It's highly reliable. It's very secure. There's a lot of innovation going on in that space. It's something very interesting for building systems as well as kind of those outdoor environments that are otherwise really difficult.
Well, I think the general takeaway I'm getting from this point in the discussion is that we started with wireless does not equal Wi-Fi, and it makes sense that if you have any level of frustration with Wi-Fi or wireless connectivity, stop and don't automatically default to saying, well, I must need the next level up in the Wi-Fi series. Yes, that may be helpful. It may be exactly what you need. Densities are being handled so much better now. There's just so many different things that are happening.
I think the bigger picture is clients really need to understand what their options are for connectivity and build a strategy around if we're looking to deliver, we want to get this outcome, this use case. This is the technology for that. And if we're working on something else, here's the technology for that. And when we run into, other options, LoRaWAN might be the option. And occasionally we do a lot of education with clients where they say, man, I want that CBRS private network because I want my cell phone to work in the building. And that's really not what it's for. If you want your cell phone to work in your office building and Verizon works great when you go outside and it doesn't work so great when you're in the building, you probably want a DAS system, a distributed antenna system, one that's able to connect those carriers and rebroadcast that signal internally. There's some overlap in what private wireless can do and what a DAS solution can do. It can also be used to support first responders. So your police officers, your firefighters, your EMTs, the radios that they use when they come into the building, they're a completely different spectrum outside of cellular and Wi-Fi. You certainly want those folks to be able to communicate with their peers when they come into the building for an emergency. Yeah. And we're seeing it on the West Coast being required for multi-story buildings or buildings over a certain square footage to have a public safety DAS solution, and seeing more and more hospitals, retail locations building DAS solutions to get the carrier networks to AT&T, Verizon, T-Mobile into the building for obvious reasons. You think of malls are kind of dying, but if you think of a retail location like Costco, you go in and you buy a cell phone, you can't activate it because it won't connect to the carrier. You might not buy the phone. There's digital displays in a lot of these retail locations that are not connected to that retailer. They're using an LTE or 5G connection. And again, if there's not coverage in the building, that retail display doesn't work. More of those organizations are deploying a DAS network to allow their customers to walk into the building and know which aisle has the lima beans or where the TV's at or where the air pump is at for Johnny's bike. And it's easier probably to have a DAS solution than compel somebody to connect to your Wi-Fi network and download an app and do a bunch of other stuff. But tons of use cases around DAS. We get a lot of confusion between DAS and private wireless and what it does, what the benefits are.
Are there anything from an operational perspective, do I have a whole new team I have to hire or consultants I'm having to pay if I'm on a private wireless, or is my normal team of pretty smart dudes and gals,
Yeah, definitely. Both technologies are heading towards cloud management where things are automated and deploying Wi-Fi solutions, pretty established knowledge base out there. It's an enterprise technology. Fairly easy to adopt. More of those solutions moving to the cloud, making them even easier. On the private wireless side, there is a lot of complexity around that core and what happens between the radio hung on the ceiling, maybe a baseband that has some of the RF functions, but not all of them, but split from the piece hanging on the ceiling. And then the reality that in a private wireless 4G, 5G network, we're SIM-based authentication. So somebody has to provide that SIM card. It has to be configured in the core. There is a big knowledge gap there from an enterprise network person to be able to support that carrier style architecture. And some of the solutions out there on the market are easier than others to manage. The ones that are easier are more cloud-based, more of a looks like a Wi-Fi access point that offloads a lot of functionality of that core. But that is why we are seeing a pretty significant interest in customers saying, I want this managed. I want the capability. I want the use case outcome, but I can't get my team up to speed on it right away.
Yeah.
Can you do it for me? And, some of the partners we work with in that space are able to deploy a proof of concept network in 2 or 3 weeks at a location and not require anybody to go through any training. So while it's very technical, it's very different, it is very reachable and something that folks shouldn't be afraid of.
My doctor had prescribed a CPAP machine for me. And the reason why I bring that up is because my particular CPAP, I got a nice one that monitors my breathing back and forth and this kind of thing. But if I want the doctor to be able to look at the information on it on this machine, I have to bring in the SD card that's in the unit, whereas normally they would connect to my Wi-Fi or the cellular network, I believe. But this particular one that I got at the point in time I got it, which is only a couple of months ago, that model had to ship without a radio that could do that. So it is missing some of the functionality that was originally intended for it. And it just makes me think about the importance of understanding the supply chain and how one goes about doing that. Is it possible to even monitor that kind of thing, or does it change too much?
No, it is. And it's really, you're making an exceptionally important point. I maybe not realizing it. However, we constantly are solving problems for clients. And some of those problems are self-inflicted challenges based on a convenient decision at the time that was made without the understanding of how all the technology they were buying was actually going to work for them. We've seen grocery stores buy Wi-Fi from an IT perspective when the business said, hey, here's a budget to buy Wi-Fi. And the business's intent was location services. They wanted to know where everybody was at in the store, how long they were spending in front of the Lay's potato chip versus the, whatever other brand that was there. And what IT delivered was a platform that provided great Wi-Fi connectivity, but it didn't do location services. Like maybe it did it with, we know where the person's at within 15 feet. Like they could be picking up salami or picking up lettuce.
There's a lot can change in 15 feet. Yeah.
Yeah, 15 feet. But the same thing applies in that office environment. We've seen vendors say, hey, we can't get this BLE chipset, but with the access points ready to go, we're going to create a new SKU, and we've got 10,000 access points ready to go. Now our delivery time is 2 weeks. And customers say, I'll take 500 of those and go out and deploy them and then find out I can't do this thing. So it's really important to, again, go back to that strategy. What does your business need? How do you deliver upon those needs and expectations or outcomes with the technology that you can buy? Make sure you're buying things more as a platform than a point solution. And we're seeing it more and more, switching, being reliant upon PoE and needing to support segmentation and security. Wi-Fi needing to support those same things as well, but then location services, BLE, additional spectrum to add voice and QoS and support IoT things. It's just a continual layering of functionality and services onto that wired network, up to the wireless, onto other things. If you're missing that one block in the whole wall, the wall very well could fall down. You may not be able to do the things that your business needs. You may be going back and buying brand new access points.
Do you trust the vendor to tell you what their real shipping times are? It feels like that may be a good time to ask your partner who maybe sees it from multiple vendors and goes, oh no, they can get this to you because they had stocked up ahead of time. So they're able to service customers faster. Because I've seen deals come and go because of shipping lead times lately. I always don't know, are they going to give you the truth, I guess, from the vendor perspective?
It's a very layered question. Again, do you trust your vendor? Yeah, some vendors are very trustworthy and they'll be very transparent. Feature functionality, you can't trust PowerPoint. You can't trust the PDF that explains what everything is. You got to look a little bit at the real world capabilities of that. We do that in our Advanced Technology Center, not only through proof of concepts, but in our own labs that we make publicly available to our customers, where we can go through and showcase those capabilities against what was on the feature list and show and even work with the vendor. If something's not working right, let's get it fixed. But we'll pull that non-working feature kind of back out of our matrix of what that vendor can deliver on. And we spend a lot of time kind of doing some of those paper proof of concepts, as well as physical ones with our clients, to make sure that they're buying the right solutions. But from a supply chain perspective, we track that really close as well. We've seen some vendors do some kind of funny things. They might have 2-week lead time, but you can only buy 100 devices at a time. And that might be fine for a lot of customers. If you're going to do 10 sites of 100 access points each, you're not going to do all 10 of them at once. So some customers get a little squirrely on that, but we're seeing a lot of improvements on the supply chain. It is at the top of our list of evaluation with these vendors today, supply chain lead time. Yeah. And we have to kind of distill that down to which devices are you looking at, because you can't just say everything because it's meaningless. But if you're looking to do an evaluation, we'll pick a few devices from each one and then look at the lead times on that. And even historically, where have they gone, where are they going?
Is there anything that you had wanted to bring up that I may have not brought up or mentioned?
I think the big takeaway is wireless is more than just Wi-Fi. And you have to understand what your options are, as well as the elements that could be part of any one of those options, so that you choose the right vendors, the right hardware, and the right deployment type for your use case, and you don't get stuck with building a network that doesn't deliver the value the business needs. Worldwide can help you do that a number of different ways. And if you're not working with us in that respect, engage with your account manager. Go out to our platform, wwt.com. We'd love to connect with you and help you out in that journey.
That's perfect. Well, Bob, thank you so much for your time.
You're welcome. Thank you.
So many good wireless options to choose from. Hey, if you've not done so already, there are helpful links to be found below the video, one of which is, of course, the 2023 Networking Priorities Report, the very same one that triggered this conversation. Worldwide Technology has the experience and the resources to help you safely navigate all of the available options, many more than we even discussed here. My name is Rob Boyd. Thank you for watching Tech 37.